I'm going to share my screen and let's talk about trees and the soil relationship that needs to happen in order for the trees to be nice and happy and healthy. And so I shared with you this image before. It is a popular image going around. That is tells us about the trees and the root system. I want to repeat that the roots are going to be found on the top, several feet, 2 to 3 feet up on the surface. And the notion about having deep roots is not really proper. You also mentioned about having the sinker roots that are going to allow the trees to sustain themselves and anchor themselves better to the ground. And so the ground plays a very, very important role because every single tree needs to be in the ground. If it's going to be allowed to reach maximum potential, it has to be in the ground. And the ground needs to be able to hold the tree. So later on, we are going to see examples of what is known as soil failure. And that is when the soil, the ground, is not able to hold the trees and the tree will fail versus tree failure when the tree is not rots and is not able to hold itself up. So the soil is going to be very important. The soil is going to be the source for water for the trees. That's what you're going to water or you're going to irrigate. And the soil has to also provide all of the vitamins, the minerals, and the organic matter that the tree needs for carrying out its life. So the soil is very important for you to understand. We're just going to go over some of the basics of what soils are and or how the soil is behaving, so that as we look at other relationship with soil and water and trees, you can begin to understand what is happening. So it is unfortunate the soil is below the ground, and so it is not that we can just start digging and start seeing what we have below our feet. So we're just gonna take some images. But here's images of just standard soil, areas where a tree has failed. The roots have been severed off and we had to remove this individual. But we see that there's going to be soil particles that are going to be attached to the trees or the roots of the trees. And you will also know that the roots are going to stand way out into the soil substrate so that the roots can acquire or find the reservoir of the water, the vitamins, and whatever else it needs. So the soil is going to be a substrate that is going to be very difficult for trees roots to grow or other plants. It has crystals, it has rocks, it has sharp edges. It is not easy to penetrate the soil, but roots have to. They must in order for them to really secure that anchorage and for them to really find all the water and or the vitamins and minerals they need. So they are forced to literally grow, penetrate, mine, figure out how to go about and extending those roots. Here are just some other examples. I may have shown you some of this before, where you have a lot of those surface roots. They're going to be on the surface because roots need to breathe. They need oxygen. And the deeper you go in the ground, the less oxygen that is going to be available to the roots. And that is why a lot of the feeder roots, a lot of the important roots that play a role in absorption are going to be found on the surface and they do not go deep. They also going to require water. So trees, plants require water. And so the deeper they're going to go, the less oxygen, the less water that is going to be available because water will be held by soil particles. And it's going to be a competition with other plants for the water. It's going to be a competition for other plants from other plants for the same resources. So they need water that's going to be available towards the surface. That could be rain, that could be irrigation. They need oxygen to breathe. That's going to be on the surface or closer to the surface. And then they're going to need vitamins and minerals. And that is also going to be on the surface or closer to the surface, because that is going to be the product of decomposition of organic matter, the leaves that are going to rot, the leaves that are going to then be absorbed into the soil. And the surface of the soil is going to be darker in color because it's going to have the organic matter, the vitamins and minerals that the tree will need. The deeper you go in the ground, the lighter the soil particles are going to get because there is a lot less of that organic matter, the vitamins and minerals. So those are the three main reasons why the roots on a tree are always going to be found on the surface, because they do not exist below or deeper. And so in an ideal world, this is what needs to happen. The trees are very, very good at recycling. So the trees are going to take the basic elements that they're going to find in the substrate, they're going to find it in the soil. They're going to use to create leaves, they're going to use to create branches, they're going to use to create a bigger body. And so as some of the leaves get dropped, they're going to fall to the ground where they are going to then rot. The vitamins and minerals are returned back to the soil where the roots are going to pick them up again, and they're going to be used for getting new leaves and new branches and new tree body. So this system of recycling is what's ideal to the plant, the trees. The leaves or the organic matter on top of the soil, it's also going to play a vital role in cooling down the soil or the area where the roots are, because excessive heat is not good for the roots. They're going to dry too quickly and they're going to die. And also it's going to conserve water, keep it available for longer periods of time. So having this layer of organic matter on top of the roots covering the ground is very important to the trees. And so if you ever get a chance to hike in natural areas that are that are not disturbed, and you go underneath a tree, there's going to be a lot of crunching, and there's going to be a lot of leaves that are going to be crunching, and you're going to be sinking. It's very nice, it's very soft, because that is the habitat that the tree needs to be very, very happy. So this is just example. It's on a lawn area, but it gives you an example of a sycamore and the number of leaves that are dropped by the tree. So it creates a really nice thick blanket of leaves. Those leaves will then rot, decompose, give back vitamins and minerals to the soil. However, we have gotten into the system where we consider leaves to be unsightly. I understand that if they're in the lawn, you need to remove them. But if there's no lawn, if there's no need to remove the leaves, you shouldn't, because that is helpful and healthy for the trees. But the notion about leaves being dirty, the notion about plant parts and litter being there, being treated as litter, it's negative, where people have remove the leaves that will normally cool down the soil, return the organic matter, and obviously many trees are going to suffer from lack of vitamins and minerals. And then that begins the cycle of having to fertilize trees. Now you're going to spend money with either organic fertilizer, which means you're bringing back some of the organic material that you took away, or you're going to use some of the synthetic fertilizers that will add a chemical to the soil. So just be aware of this. For an ideal world, the trees would like to have all or as much of that organic matter left on the ground for them to be happy. This is more of what we have here. It is unknown in many areas the damage that has been done, because obviously there has been a need to build houses. So there's going to be a highly compacted area. There's going to be pipes going left and right. We don't even know the history of that in many areas. But this would be a typical area, and I'm going to say soil area, for many of the trees that are being planted around here in the city. So it's been trenched, so it gives you an idea of where the roots are going to be growing or where they will have to be growing. But if we were to take a deeper and just a generic drawing of the soil profile that are known as horizon, so you should know that word, we're going to find that there's going to be multiple layers, and this is going to change depending on where you are. So the soil could be very different from one area of the city to the other because of geological factors. The soil may be different as you get closer to the Elliott River because of years of deposits versus on top of a mountain that is going to be very rocky. So just be aware that soils could change and are going to be suited for one tree and not another. But if we look at just the layers, we're going to divide them into the O layer or the O horizon, which is mean O for organic matter. So this is going to be the darker color, the surface that is going to have all the vitamins and minerals for the plant. So it's going to be very dark in color because of the decomposition process. And below that is going to be the A horizon. So together the A with the O and a little bit of the B is going to be referred to as the topsoil. The topsoil is the ideal medium soil area for plants and trees to grow. So that's where the roots are going to be held. Uh, when you go deeper into zone B or horizon B, that's going to be known as the subsoil. Which is going to be lighter because there's going to be just a little bit of water that may go that deep, or in a little bit of the vitamins and minerals that can make it that deep. But otherwise, they're all going to be on the top. And then layer C, horizon C, is going to be known as kind of like the parent rock. This is where if you dig deep enough, you're going to find rock that over time has been covered or erosion has created some of the soils in place, or some of the soil may have been brought down from the mountains or may have been accumulated through wind or some other natural factors. So again, this is just a generic drawing of the soil layers so that you can see where some of the roots may hang out or not. Here is also the makeup of the soil. So regardless of where you are, there's going to be three main components of the soil, and this is going to be the mineral components. We're going to have the largest component that is going to be sand. The sand is going to be the product of many years and many dead algae from the ocean. Not algae, animals from the ocean. I'll think about it later. So they accumulate the silica that when they die, they get decomposed and broken down. And the right word is coral, sea coral. They'll eventually turn to sand. And so that's one way. Other ways would be by the grinding of rock that would also eventually create some kind of sand. But most of the sand that you'll see out in the flat areas were probably from animals, corals, back in the days when there was a lot of oceans or different types of oceans. And as the land receded, the waters receded, then the land came up. Some of the sandy areas may still be there. So that's going to be the largest component. Next is going to be followed by silt, which is right in the middle. Sometimes people refer to soils as being kind of silty if there is a higher percentage of this component, silt component. Or sometimes people may refer to soils as being sandy because they have a higher percentage of the sand particles. And then the smallest component is going to be what is known as the clay particles. Long Beach has predominantly clay soils. It is very good to grow plants as long as you provide certain type of help. But clay particles are going to be very, very tiny. And so together, the sand, the silt, and the clay mixed in certain percentages are going to create the different soils that we have out there. Add the organic matter, and voila, you have a component that is very good for plants to grow. So just be aware that soils are going to have this three main component in different percentage, that it's all going to work together to provide that tree with the good living area. Here's a generic drawing. This is referred to as a soil triangle. And so there are many, many, many ways, ways that you can estimate the percentage of the different components. Ideally, if you want to know what's in your soil, if you want to know if you have any toxic compound, anything that is killing your soil, some of the history behind your soil, it is highly recommended that you do what is known as a soil analysis. You take a random samples from different areas of your garden, and you send it to a place like the Plant and Soil Lab in Orange County. I'm not promoting it, but that's the closest one we have to Long Beach. And they will give you a reading of what you have. And if there's a problem or a lack of a certain vitamin mineral, then they'll tell you how to correct it. If you have an excess of something, they'll tell you, or if you have any kind of toxic components that will kill trees, they'll tell you. But otherwise, you have here just by percentage. So when you have a 50% clay with a 30% sand, and then a 20% sand and 30% silt, that puts you right here. You have kind of like a clay-like soil. And you can look at the different percentages to determine whether you have a predominantly sandy soil here where the percentage keeps getting higher. That will be the line below. Or a clay-like soil where it keeps getting higher as you get to the top, or a silt-like. Ideally, loam right in the middle where you have a good percentage of the mold is the holy grail. That would be the type of soil that any plant would love to be growing in, but it's not real. Most soils are either going to have a higher percentage of the clay, making them clay-like, or many soils will have a higher percentage of sand, being sand-like or predominantly sandy. So just be aware that you can still grow many trees in these types of situations. There might be some things that will help them be healthy, but in most cases, the soil that you are given or the area was given is what you're going to have to work with to grow the plants. There is no such thing as bringing new soil, bringing fresh soil from anywhere, because that's just a man-made product. So whatever is the gift that you were given below the ground to plant the trees, that is where the tree needs to grow, and you can help it along. The texture of the soil is going to be made up of those, but also the texture or the different components are going to determine how quickly the water is going to penetrate. So this is referred to as the drainage. So when we look at sandy or soils that are predominantly sandy, where the soil particles is very large, there's a lot of space in between the soil particles, the water has no problem in penetrating and going deeper, often way below the root zone, which means that now the plant is no longer able to use that water. And then on the other spectrum, you have the soils that are predominantly clay. The clay particles are so small that they're going to be very close to one another, making very small tunnels, which is going to slow down the movement of water. So the drainage on clay-like soil is going to be very poor. So water is going to move very slow. This is more important as we talk about water and not wasting water. So if you know you have soils that are predominantly clay, then you should not be watering as long. So maybe for 5 minutes, let the water seep because it's going to take some time. And once the water has gone and into the soil, then you can water for 5 more minutes and let that water seep in. Otherwise, after 6 minutes, 7 minutes, water is going to begin to drain out into the gutters and you're going to lose it and you're just going to be wasting water that's going to go into the ocean and bring a lot of pollution to that. So determining the types of soil that you may be dealing with can also influence how you water or how often you water, how long you water, and how quickly is the tree going to be need to be rewatered. Clay-like soils or clay soils will dry out a lot slower, so there's no need to water them as much. They are able to retain the humidity, the water for a longer period of time. So it's can cause the problem of sogginess, can cause a problem with being too wet, where they now exclude all the oxygen, causing a aerobic condition that is not going to be good for the roots. And that's when you may get root rot or a bunch of other problems. So yes, soils do play a major role. The soil, water, relationship, the soil-water balance is very important for the health of a tree. So keep that in mind. This is going to be the ideal soil that trees would love. And again, ideal because this is probably a fantasy. So if the tree had a choice, they would always like to grow in soils that are about 45 to 7% inorganic. That's going to be the sand, the silt, and the clay in the ground. The soil and the roots need oxygen. So a soil that provides about 25% oxygen would be ideal, as well as the plants need water. So there has to be water present at all times. The soil-water relationship is going to be the more crucial. If you add too much water, you're going to be losing the oxygen, the air, roots are going to rot. If you don't have a lot of water, you're going to have a lot of good oxygen, but no water, which means now there's going to be wilting, there's going to be stress on the tree that will make it prone to other problems. So the secret to having healthy trees is going to be the balancing of the air and the water in the soil. And a very small percentage is going to be the organic matter, that is the rotten leaves, that is the rotten branches, anything that would decompose, releasing the vitamins and the minerals back into the soil. All of this is done with the action of having healthy soil flora, having healthy bacteria, fungi, protozoa, earthworms, all of those organisms that make the soil into their home are going to be very important. They are the ones who are going to feed on the rotten leaves. They're the ones who are then going to help to fertilize the tree via their biological waste, or what we know as the earthworm poop or some of the insect poop. Uh, so again, keep this in mind. We'll talk about it and bring it in a couple of other sessions, the ideal soil that trees will like. And so the space in between the particle is very important. Keeping in mind that roots need oxygen, there has to be spaces in between the soil particles that allow for the oxygen to be brought back into the soil because tree needs to breathe. And so when you look at the particles, you have the different particles that are going to be close together. So here's in the middle, the example of the clay soil, the clay particles being very, very small. So they kind of overlap over one another. The spaces between the particles is going to be very narrow. So they have poor drainage. They have poor oxygen in them. To where you have the opposite on the sandy soil, you have the clay, the sand particles that are going to be very big. They're going to just be close to each other, and they're going to allow for larger gaps, allowing for very good drainage, very good oxygen, but very poor water retention. It is the makeup of the particle that is going to allow it to retain the water. And so clay particles are going to retain water way, way better and much, much longer time than the sandy particles. It's just the makeup of the soil particle. In the optimum soil, yes, this is what the plants want. You have a combination of both. So you have some of the gaps, bigger gaps within the sandy soil being filled in by some of the clay particles naturally, kind of blocking, slowing the movement of water, and also retaining water via the clay particles for a longer period of time. And in the same manner, the vitamins and minerals are held by the soil particles, and that's when they are going to be available to the plants. So that's another very important thing that you need to be aware of, that it is this water that is being held by the soil particles that the tree can drink. It is through this connection of the soil particles with the root hairs that the tree is able to exchange the molecule of water or absorb the molecule of water from the soil substrate. It is not the free living water that is flowing out there that this tree can drink. And in the same manner as the as the organic matter rots, the vitamins and minerals are released into the soil. then the soil particles cling onto those vitamins and minerals, and it is from the soil particles that the tree is able to absorb the vitamins and minerals that they need. It's not the rotten compost. So the soil, whatever is being held by the soil, is what's available to the tree. And so this is creating bigger spaces in between the soil particles. Bigger spaces is easier for roots to penetrate and grow through, so they don't have to mine in a narrow area. And then it provides good drainage to allow water to drain out, but allow the soil to return and provide that happy needs for the tree. So here is the spaces in some areas that have been that have the soil particles, and the blue in this case is the water that is being held because you also have a problem with compaction. I mentioned that our campus is very compacted because there has been construction here for every single year that I've been working. There's always equipment. All of that equipment, all of those cars driving on top of an area will eventually compact the soil, creating or removing the space in between the particles and creating dead zones. Sometimes you can compact the soil 90%, almost 100%, which is almost like cement. And that's not going to be suitable for plants to grow, and trees are not going to penetrate that area. So it's also important for you to understand that compaction is going to be something that will occur on soils that are predominantly clay. And that is because of the nature of the clay particles. They are kind of disc-like, they stack on one another, they get pushed together, they stack perfectly, and so they can remove all of the spaces in between them. I always like to point out is a trail. A trail, when you go out hiking, is an area where people keep walking on top of it, the same area, compacting it. Eventually you have plants on either side, but right on the trail, you have no plants because the soil is so compacted that it doesn't allow for any plants to grow. So clay soil can suffer from compaction. And the magic of organic matter is going to be what is referred to as soil aggregates. Any problem that you're having with soil, any problems that you're having with lots of vitamins, lack of vitamins and minerals for your trees can be resolved by adding organic matter and leaving the leaves behind to rot, leaving the bark behind to rot. I know that people consider us messy, but that is vital. That is organic matter. That is necessary for having a happy and healthy soil. It is also important for you to think about soils as being a living entity because they are. There are hundreds of thousands of millions of organic organisms in the soil that are constantly working, recycling, and providing what the plants need. And so leaving the organic matter or adding organic matter is a way that you can say, I am feeding the soil because you are feeding the organic matter that will take that rotten vegetation and like decompose it and digest it and release the vitamins and minerals. But through all that action, the organic matter will, through the action of organisms, fungi will rot. And what's going to happen as a byproduct of the decomposition process, there's going to be a product that is going to be known as humic acid. Humic acid is going to be very, very important because it's going to act as a binding agent. The humic acid will then bind soil particles that are just going to be out there free living, creating what is known as soil aggregates. So it can take the different clay particles and kind of create blocks or clumps of them. By creating the clumps, now you have areas that are going to have a lot more oxygen, that is going to improve the drainage. Now you have made an area that is much better for plants, roots to penetrate and grow. So Having healthy soil with lots of organic matter is going to eventually create lots of soil aggregates. It's going to smell very nice because it's going to be continuous action of decomposition. It's going to smell earthy, and it's going to become kind of clumpy because those are the soil aggregates that are going to be formed. And ideally, with time, you can work with the soil and make it very healthy for the trees to grow. And then you're going to have happy plants and happy trees that will have everything they need. So by creating the soil aggregates, by adding the organic matter, you can improve the drainage, you can improve the water retention, you can improve the vitamin retention, you can improve the oxygen, you can improve and enhance the organisms, beneficial organisms in the soil. And having a lot of beneficial organisms in the soils are also going to act as a protective agent for the roots. So if there is a pathogenic organism that happens to land around the root zone, then the beneficial organisms are going to be antagonistic. They're going to compete. They're going to fight off, and they will help the tree in or protect the health of the tree. So happy soils. So here's just a drawing of the soil aggregates, creating the big pores or the bigger areas. You have the different particles that have been bounded together. Now you have larger pore space or the space between the soil's particles that improves the drainage, improves everything else that the plant needs. So this would be what you would like. And again, regardless of whatever soil you get to work with or you were given, if you add organic matter, it will bring it to this point where it's going to help. Even having sandy soil, adding organic matter, mix in with the sandy particles will enhance the sandy soils and make them more suitable or better suitable for plants to grow. The pH is something that we don't really have to worry about here. This would happen in areas where you have a lot of rain that will drain or leach out some of the elements. And so sometimes there will be an excessive removal of some of the atoms that are going to create either an acid-like or an alkaline type situation. And we don't get enough rain here in Southern California for this to really become a problem, but back east or somewhere else, then you might think about if there's a problem with a tree, then you can think about testing for the pH of the soil. Around here, we have what is known as either neutral or slightly acid. Again, organic matter, even if you have a problem with your pH, organic matter is going to be what's going to be solving the problem. But again, just be familiar with pH, know what it is, but know that around here is not a serious problem. In areas where there is a problem, you may also get a deficiency or an increase in certain elements to the point where it may be poisonous to the plant. Later on, we'll talk about fertilizers and vitamins and minerals. But here is showing you that if you have acid soil, iron, copper, zinc is going to be available to the plant in larger amounts, probably too large, and they could be toxic to the plants. And a few others like nitrogen is going to be available in less. And so most of the elements are going to be available in the neutral. You can see available in a good amount. And then when you go to the other extreme, the alkaline, once again, certain elements are going to be bound and not be available to the plants, and other elements are going to be available in such large quantity that it could be poisonous or toxic to the plant. So just be aware, again, not here, but in other areas, Eastern US, also Northern California, not Northern US, there may be problems because there's more rain in those areas. But we talked about the organisms, having a living soil, so just a generic drawing of the bacteria, the fungi, even the gophers making holes, insects living on the leaves, feeding on the branches, feeding on the leaves, pooping in the soil. Eventually the poop gets eaten by a different organisms and it gets processed And all of that is going to feed the soil, creating a happy community of insects that are going to make up what is known as the soil flora, which flora means plants, but it's talking about all the different organisms. There's going to be macroflora, that will be the bigger animals, the insects, the gophers, the earthworms, or there's going to be the micro or microscopic flora, which are going to be bacteria, protozoa, fungi, and the other smaller organisms. So feeding your soil, because you're feeding all of these other organisms that make their soil their home, that are helping the tree and or assist the tree or living in harmony with the tree. The word mycorrhiza, you should be familiar with, or you should know it, because when trees and plants started to colonize the land, they had to make partnerships, beneficial partnership with other organisms. So mycorrhiza is a group of fungi that live in the soil that form that partnership with trees. You can buy mycorrhiza spores that you can inoculate baby trees or the roots. And so, as mentioned before, the soil is not a happy place for trees to penetrate. It's very difficult. Uh, and so if the trees don't need to, they won't. However, the fungi has what is known as the strands, which are known as mycelium in a fungi. The fungi has a much easier method of penetrating through the soil particles. So they're a lot thinner. And so by building a relationship with the tree, the fungi are going to connect to the roots of the tree. And this fungi is able to reach out further and bring back vitamins, minerals, water to the tree, and as well as provide an area for defense, a defense mechanism for pathogens. As a result, the tree is able to take advantage of soil that is further away, that is being worked on by the fungi, and the fungi will absorb those vitamins, minerals, water, and they'll then give it to the tree. In return, the tree will pay the fungi with carbohydrates, with sugar, and other resources that the tree makes through the process of photosynthesis. And so it is a beneficial relationship where the seedling or the plant, the tree benefits from having the fungi bring them vitamins, minerals, water, and the fungi benefits by being fed by the tree. The mycorrhiza fungi is also very sensitive. So if you use any kind of chemicals, they are going to be sensitive. You're going to kill them. In happy forest, there is an abundance of different types of mycorrhiza. As forests get destroyed, those mycorrhizas go away and they die. And so they may get replaced by a couple of weedy mycorrhizas here and there. But be aware, because if you are planning on putting trees in areas that might not be as suitable for them to grow, having the roots inoculated with a mycorrhiza will put them in a much better place of surviving than if you were just to take the fungi by themselves, or sorry, the seed or the tree by itself and just plant it. So does the soil still have mycorrhiza? The answer is yes. So you don't really need to inoculate them, but it just helps if you wanted to provide it right at the root when you plant the seed or the tree. So here's just some drawings and or now my photograph of a slide where it shows the fungi strands penetrating the cells, making that connection with the roots. And as a result, the roots are going to abandon the root hairs that we talked about because they have no need. The fungi is doing all the absorption. And instead, the roots are going to be changed and modified into these little knobs that will be the site where the fungi will have that interaction with the root. So this is what's going to happen to the roots. And there's just a drawing showing you uh, where the action is taking place. So that's going to happen. However, we live in the city. We have urban soils. We have a lot of cement. We have very little areas where soil or water can be absorbed. And then wonder, why are we having so many problems with trees? Uh, it still amazes me the fact that we can grow many trees in this type of environment, but this is hardly what the trees really like or want. This is not ideal, but they're survivors. They'll do whatever it takes and they'll survive. But we have a lot of tarmac, we have cement, we have reflected heat. So I mentioned organic matter having a layer keeps the area cool. Here's the opposite, where the cement, the tarmac, is going to absorb the heat from the sunlight, making this area really hot. I'm sure you have walked into cement when it's 90 degrees. It can burn. And so think about this as you are may come across trees that are going to be unhealthy. It's like, why are they unhealthy? Well, because many things could be happening around them that you don't realize. Here we have a sycamore in Naples Island. It's hardly the place to have the sycamores. Gets pruned every year. This is a big tree. On one side, it has the ocean, salt water that is not good for them. On the other side, it has a house. Where are the roots? It's amazing that it's still alive. It's amazing that it got to that size. But somehow it's making a living. So it's still there. Or they're going to start breaking cement because they want to breathe. The cement is not going to allow them to breathe. So yes, they will break the cement because they need to open the way for the oxygen to return to the roots. And so this is going to happen. It's inevitable. They're going to live sidewalks, probably not the best street, not the best spot, but the roots are going to keep on growing. They all keep getting thicker. And so if the cement walkway is underway, they're going to lift it. They are very strong. They have no problem. And so this is going to cause a problem with the infrastructure of the city, problem with sidewalk and falling, tripping hazards. And each year the city is going to replace certain sidewalks. So, or in parks where there is hardly any areas. I mean, here's a little bit of soil, but in this parking area, there's no soil. It's just a tiny planter bed. The roots extend uh, hopefully many meters away from the stem, but there's no water, there's no vitamin, minerals, no organic matter, probably no organisms that are living under this cement. And the trees are planted and hopefully they'll give shade. In this case, they are seriously being hacked where the purpose of providing shade is not even given to them. So why even have the trees there to begin with? I mentioned before about suckers. So here is a black locust, and just to show you the relationship. So that's the tree that died. And then you have areas where the roots are still alive, even though the tree is no longer alive. The roots are, and this clue is the fact that there are suckers, branches that are coming from the ground. And here you can see them straight on the grass, and they're also going on this side that I did not take a photograph. But here's exactly what happens. So the roots will extend out wherever they can. And in this case, if they're able to survive long enough to go underneath the sidewalk and go on the other side, yeah, they can then take advantage of whatever's out here. Otherwise, they're just going to follow whatever open soil that they have to get the required elements. Or sometimes we grow them in very small containers and they get too big. And this one here is it's just died. It probably, the entire soil that it had became roots and then it just wasn't suitable for them to grow. So they'll die, no problem. And you have here really big trees as a street tree. Uh, again, only has half of the area, whatever is being able to absorb through this yard. So yes, that's where the roots are going to be. The roots are probably not going to be over here on the uh, street side because that's not suitable for them. Or this other one, it's amazing, but yes, tree can tolerate all this, or this other one. And soil failure could occur sometimes when the soil gets really, really wet and you have a tree that begins to lean. If the soil fails, that means it's not strong enough to hold itself in place. The tree will collapse. And so we have here, perfect example. So when the soil fails, the tree will still, or the roots of the tree are still going to be clinging on to the soil particles. And they are going to create what is known as a soil plate. And the roots were happy, the roots were healthy, the roots had no problem. It is the soil that did not support the tree, and that is why the tree fell. So here's a different example, a very large pine. And you notice there is a very broad area here. That is the soil plate. That is a soil failure. So the soil back here was not able to hold the tree upright. And as the tree fell, then the roots severed off and they broke off, and now the tree has to be removed. So when you see this soil plate still attached to the root system, that is then referred to as the failure of the soil. For whatever many reasons, it was not able to hold this tree any longer and the tree fell. And there's the plate with the soil and the roots. Or in this case, it could be not soil failure, but some of the roots that are cracking the soil. So cracking the soil underneath the tree is not good. So just be aware of that. So if you see trees and you move them and you see cracking or soil movement or just literally cracking of the soil, it's not good. So here is a combination of probably some root failure and the soil that is cracking because it's not able to hold itself together. So this is not good. The tree is leaning. Luckily for this tree, it is in a golf course, so it's not a big problem. There was no need to remove it because it was posing no hazards to anybody. Or here's an 800-year-old tree, oak in the valley, LA Valley. And at some point they decided to build a shed next to it. So gigantic tree and no area, an unhappy area for the roots to grow. Here's a different view of that tree. And sadly, the tree came down. So this was strictly root failure. There were no roots to hold the tree. The weight of the tree and the mass of it and the base was holding it upright. I mean, the roots were gone already. Or the little ones that they already had was keeping it alive. But here's perfect example. The tree just fell, the roots severed off. And so this is root failure, that roots could not hold the tree. And so this is the final slide. So this is what I like to say, probably a tree growing in a nice area. It's a cedar that we'll see later on. But notice, even the whole front yard belongs to it. The branches are allowed to spread out. The tree has really nice form, really nice shape. So I would say this is a tree that is loved, or hopefully it's been loved by somebody and is cared for properly. The grass I can live with, but again, not a deal for the tree, but it's at least it's a very nicely shaped tree. This is right at the border of Long Beach and Lakewood. It's Carson and Clark by the golf course. So I think that is the last slide. So with that, is there any question that you might have about soil?
Yeah, Professor, I have a question.
Go ahead, Jake.
So I have a citrus tree in my backyard, and it was pruned. The landlord had it pruned, and was pruned very poorly. And I noticed around it, it has been really hot, but I've noticed that the grass has started to die. Is it from the roots
Uh,
taking the water from the grass to kind of as a survival method?
no, that is known as allelopathy, but that does not occur in citrus. So if you have grass around the citrus tree, I'm going to recommend that you get rid of the grass.
Wish
And
I could.
we'll talk about that later. But ideally, the grass should be at least 5 feet away from the trunk of the tree. So if you can get rid of the grass, do so, because at the end of the day, yes, it is competing with the roots of the tree. And if you know grasses, they have a lot more massive root system. And so they'll be able to take more water and quicker than the tree. And yes, over time, the tree will suffer or will be getting a lot less water. So get rid of the grass from the base of the tree if it's getting close to it, to the trunk.
It's about 4 or 5 feet away from it. I wish I could get rid of it. It's not mine. I live with my landlord, so.
So why don't you take a photograph of the area and let me see it? And
Okay.
then I can give you a better diagnostic on it.
Okay.
All right. Any other question? All right, then I'll stop the recording and I'll see you guys. Have a good day. I'll see you guys
You
next
too,
time.
Professor.
Uh-huh.
No, have a good day. You too.
All right. Thanks a lot.